Okay, let's look at the work of home. I want to take some questions. Okay, we have a full house today, so I'll try to keep it down. So I have the most incorrect on this homework was 12, 14, 16, 18, and 20. But I want to start number 2. Number 2 is a classic Regents question in terms of what is an electrolyte. Okay? An electrolyte, like we talked yesterday, review is a chemical that when it breaks apart into free ions will be able to conduct electricity. So my friends in chemistry here, I'm asking you which one makes the light bulb bright, or will make the light bulb, or Ernie as we like affectionately call our demonstrator, okay, light up. And of course, we should know that the following are electrolytes: acids, bases, and salts. All of those break apart into ions. So 2 is kind of tricky, so I want to make sure I go over it, although most of you guys did okay with it. NaCl is our salt. Clearly, party people, that is something that will conduct electricity. Why? Because NaCl, like all ionic compounds, if they're soluble, will break apart into its ions. And when you have free ions in solution, that's what conducts electricity. We've talked about it. I've drawn that. Now, C6H12O6. This is a molecular compound. What kind of bonds exist here? Covalent. And covalent compounds do not break apart in ions. This is not the first time we've talked about this, is it? Something that's covalently bonded does not break apart into ions because they're not made of ions. If I was to ask you which one of these two makes the boiling point go higher and the freezing point lower, you would say this guy breaks apart into more stuff. So sugar does not make the light bulb bright, is not an electrolyte because it's not made of ions. To conduct electricity, we need free electrons like metals have, or you need free ions. Now, these two look like they're all made of nonmetals, and it's correct. This one is made of nonmetals, this one. These are both molecular compounds. So it looks like there's only one choice. However, this is an organic acid. We haven't done organic chemistry, but we're going to learn this is a organic acid, a Cu group. Now, this is actually vinegar, or as we say in this town, vinegar. Now, if you needed to know that, this course lets you know that. They're not trying to be tricky. So if you go to the table of elements, or I should say, sorry, the table of acids, you will see the one that's posted is right there. Oh, wrong one. Hard to do backwards. So right there is the organic acid, vinegar, or acetic acid. It's already given to you. That's an acid. Now, some people are saying, well, you said, Mr. Grodsky, to be an electrolyte, you have to be an acid, base, or a salt. Clearly, salts are electrolytes. That's what our body uses to conduct electricity in an aqueous solution. Well, wait a minute. Aren't bases electrolytes? If I write NaOH, we should know this to be an Arrhenius base. Breaks apart to Na plus and OH minus. That breaks apart into free ions. So why isn't this a base? Well, as we're going to learn in organic chemistry, this is an alcohol. Look carefully. Just because you see an OH does not mean something is a base. This OH is a hydroxyl group. It looks different. Look, look, look. NaCl. This is an Na plus attached to an OH minus. It's ionic. This right here is a carbon attached to a hydrogen, attached to another hydrogen, attached to, what is this? Methanol. Is this made of ions? Is this made of ions? No, it's molecular. Even though there's an OH we call functional group in organic chemistry that we're going to get to, this is not a base. So don't be a robot. Don't just say OH makes a base. You have to understand it has to be a compound that's a salt that has a hydroxide. A positive with a negative. This is a polyatomic ion. This is not. This is just O bonded to H bonded to C. This is not. This is an alcohol. So the Regents loves, excuse me guys, loves to throw alcohols into these equations for you to pick them thinking they're bases. We're going to work with alcohols and talk about alcohols when we get to organic chemistry, but I have to show you that this is not a base. This does not dissociate to hydroxide. How do I know? This OH is attached to something that is what? Molecular. These are all bonded. Is this an alcohol or is this a base? If I write KOH, is that an alcohol or is that a base? A base. It's a group 1 ion that's +1 attached to a hydroxide. If I write this, CH3, CH2, CH2, OH, what is that? Bunch of carbons and hydrogens. Then there's an OH. Is that a base? No, it's something that's bonded covalently. It's an alcohol. It's not acidic. It's not basic. It looks like a base because of the OH. So if you see carbons and hydrogens, then an OH, you know that's not a base. It has to be something, a metal and an OH minus. Okay. Now, number 12. Let's do number 12. Let's get there and go on to today because I want to spend a lot of time in lab at some point. Where is my little thing here? People like auditing my class today? I don't know. So number 12. Given a reaction equilibrium, who are the two Bronsted acids? Whoa, we just did this yesterday, so let's review. Okay? So at equilibrium, if I'm at equilibrium, two Bronsted bases are. So how do we do this? Well, my friends in chemistry, let's go find, this is the current scenario, this is the future. What's happening as I go from left to right? HSO4 becomes what? SO4 minus 2. What happened as it went forward? Did it gain an H or lose an H? Lost an H. And we learned when you lose an H, you're donating an H. What do we call that? Acid. This one accepted. It's a base. If it's an acid on this side, it's a base on the other side. If it's a base on this side, it's an acid. And if you don't believe me, okay, what just happened? Oh. If you don't believe me, go back 20, which one I was doing, 12? Yeah. All right. Go back in the reverse. How does SO4 negative 2 become HSO4? It must have gained an H. Bases accept protons. Acids donate. So the two bases are clearly H2O and SO4, choice A. All right? Maybe not. Okay, next one. Next one was 14. Okay, that's another one that most people got wrong. I'm just going crazy here. Edit, undo. And let's go here. So number 14 was the next one people got wrong. In this reaction, getting too big, the conjugate acid-base pair, what does conjugate mean? Same chemical. So the conjugate acid-base pair, there's just one pair, isn't there two? Here's one pair. So conjugate, the same chemical. No, no, no. Hey, same chemical plus or minus an H. So that's why D is the answer. Okay? Also, the most 16 was another one that most people got wrong. What's a pH value that represents a solution with the lowest hydroxide concentration? If I've got a low hydroxide concentration, I tend to be acidic or basic? Acidic. So the most acidic pH is a 1. Okay?
Can you explain 15?
Sure, absolutely. An acidic solution can have a pH of, well, when we're above 7, we have more hydroxides than H pluses or hydroniums. 7 we have equals, so the acidic solution is the lowest. A low. Remember, what does that mean? If I have a low pH, what does that mean? That means my number for my hydroxides. Think this way, people. This is the way I taught you. Okay? You take the H plus or the H3O plus concentration, times it by the hydroxide concentration, it always equals 10 to the negative 14. So, if this number, when it was neutral, this number was 1 times 10 to the negative 7, and this number is 1 times 10 to the negative 7. So, Rachel, when this number gets bigger, Let's say now it gets bigger by 100 times. Now it's 1 times 10 to the negative 5. pH is about this guy. What's the pH of this solution that has an H plus? 5. So the number gets smaller, the exponent's getting smaller because the number's actually getting bigger. Right? A smaller negative exponent means a bigger number, but the actual exponent we're using numerically is getting smaller. So as the pH drops, this gets bigger, and that's what acidity means. Okay? If you have that visual, understand you don't get that wrong. Okay, almost done with this 18 or 16. We do 16 yet? Yeah, we did 16, so 18. We kind of group together. An OH ion concentration greater than H+. That means that this is bigger. Would be an acid or a base. When you have more hydroxides than H3O+, remember these are synonymous with H+. So I've got more hydroxides than acids, I must have a base. The question is, which one's a base? Is choice D a base? CH3OH, what is this? Rhymes with alcohol, exactly. Alcohol, you guys are rappers. Okay, good. Now, what are you looking for? You're looking for the base. Group 1 ion with a hydroxide. This is an acid. This is an acid. This is listed as an acid on table K. Table K. L is listed as a base. It's more hydroxides, it's a base. All right. And lastly, number 20. There we go. The concentration of H3O+ is equal to 1 times 10 to the negative 4. H3O+ is water holding on to a proton. Where did the proton come from? The acid. So H3O+ is the acid solution. Therefore, it's 1 times 10 to the negative 4. The pH is 4. And because it's less, because this number is bigger than this number, there are more H pluses, and it's acidic range. Choice D. Any questions there? All right, well, rock on.
What number is this?
That was number 20. Okay? All right, moving forward. Maybe. All right, so let's go to new thing. All right, party people, here we go. This is the last little piece of this unit, and we're done. So we're going to finish this little piece today. We're going to finish, hopefully, our lab from early this week, and then we're going to start a new lab tomorrow and hopefully finish the same time. But your lab tomorrow is on this. So my friends in chemistry, today we're talking about neutralization reactions. What does neutral mean? What's that? Yeah, so neutralization reaction means that we don't have any acid or base. Now I used to do this demonstration right now, and I don't do it anymore because I actually hurt myself. Okay, and here's what I used to do. I took, an unbelievably strong acid. Okay, I took a strong acid. So I took an acid right here. Now we know acids have H pluses in them. A lot of them. Strong acids completely dissociate. So I took a strong acid. Okay? And then I took a piece of denim jean. So I took a piece of denim jean, like a square, inch by inch. Okay, so a piece of denim jean, inch by inch. And I dumped it right into the strong acid. People watched, and within 30 seconds, the denim jean just dissolved.
That's so cool.
Yeah, it's pretty cool. It's like Then I did this. I took a strong base. I don't do this anymore, and I'll explain why. Now, a strong base has a great number of hydroxides in solution. That's the Arrhenius definition. And I did the same thing. I dropped a piece of denim, square, inch by inch, into the base solution. In about 30 seconds, the square dissolved. I wanted to show people that strong bases are as dangerous, sometimes we use the word caustic, okay, as strong acids. In fact, liquid Drano that you guys tested Tuesday is actually sodium hydroxide, a strong base. So that can eat away any, I don't know, hairballs or whatever might be clogging the sink in your bathroom or your house. So strong bases are as dangerous as strong acids. No life exists in these pHs. This pH, okay, could be in the range of something like 0 or -1. This pH could be in the range of somewhere of 16.
But like water's like 7, but is there stuff in like 6 and 8? Like that's also like.
Yeah, we can deal with things that are probably from 3 to 10 comfortably. After that, it becomes uncomfortable to eat that. It becomes actually dangerous. Like, you know, lemon juice or vinegar, okay, is acidic. And that's about a pH of about 3. Anything getting more acidic than a pH of 3, it would actually start hurting our epithelial cells, killing our walls or lining, okay, our skin. So even though you know if you have an open cut or something, you bit your tongue or something, and you had some lemon juice, that would sting. But you wouldn't be start eating away your own protective lining at a pH of 3. Yes.
How is it over 14?
Oh, well, it's a great question. Okay, if you can have pHs that are smaller than 0, so if the pH is 16, what's the concentration of my H plus? 1 times 10 to the negative. If the pH is 16.
Oh, then.
Oh.
Okay.
Oh, okay.
Oh, H actually.
That's right.
Yeah.
Okay, now.
But then to get it to 14.
Right, to
That's
get it to
what I'm
14, what must this concentration be?
Negative
1 times 10 to the
2.
2. Okay? Now, chances are probably 16 is a stretch for solubility, so I probably should say 15 is more accurate, so this would be a 1. And that would mean I'd have about a 10 molar solution, okay, of some kind of compound. That's possible. 10 molar solution of a strong base. Just like the -1 for the reasons. You don't think in terms that way, but this is pretty strong. Now, so I dumped both of these in, and I don't do this anymore because I made a mistake, and I'll show you. So I showed you that the denim in a strong base dissolved. The denim in a strong acid dissolved. Whoa, dangerous. You know what I did? No, did it something worse. Took out the denim, took the acid, took the base, poured it into each other, stirred it, drank it.
Did you?
No, you didn't.
Yep.
You thought it was going to create water and then.
Well, that's good. See, by adding this together into the same container, you should realize what? That the OH minus is going to react with the H plus, and they're going to neutralize each other. And what we're going to make is essentially water. Now, in truth, it's salt water. Okay, let me explain. I took my strong acid, which was hydrochloric acid, and I took NaOH. Now watch. What does this break apart into? H plus and Cl negative. This breaks apart to Na plus and OH minus negative. They're both strong, so they're completely associated. Now we write it like HCl, but it's really like a what? A wedding of... Yeah, they're not really together. Okay, they're really what? If I put aqueous or the strong, this breaks apart. So guess what? The H plus finds water. Is water a good electrolyte? Does it like to exist as an ion? No. That number right here tells us, this -14 number tells us. So water, when there's a lot of ions, will come together, or OH and plus will come together to make water. What else do we make? Right, NaCl. So my friends in chemistry, I was drinking salt water. And it was neutral. It was salty, but it didn't burn me. At least for the first couple of years that I did it.
Oh, years.
Yeah. So the problem is, neutralization is what I'm talking about today. neutralization really means that we're matching the H pluses from the acid to the hydroxides to make the water, to make it safe, to neutralize the what? I don't know, the danger of the strong base and the strong acid. However, if I'm off by a little bit, if I had a little bit more hydroxides than H pluses, okay, pH is very sensitive. Something I get into the AP course. pH can swing very fast, and you're going to see that firsthand tomorrow. Okay, if you were to plot how pH changes with volume of something you're changing with, the pH can fly up very fast. Here's my pH of 7. That's called a pH curve or titration curve. So swings in volume swing the pH. So if I'm off by a little bit, okay, then the pH, which should be at 7, could be at 11 or 12, at a dangerous one. Okay? Now what happened to me was not too much hydroxide. Okay? I had too much acid the last time I did it, which means there was not enough hydroxides to neutralize. So what happened was I felt a burning sensation after I was all cool and I drank it. All right? Now because I have messed with all my classes, felt like I hurt my back and, he cracked it. No one believed I was hurt, okay? So I was actually feeling pain. Now, when I did this demonstration, I knew that I was drinking something that could be potentially dangerous. So I always had some vinegar, which is a weak acid, and I would drink that if I thought I had too much hydroxide to neutralize. And I also had some baking soda solution. As we just talked about, baking soda is basic. That's what's in your... What's the name of that drink? Essentials or something?
Essential.
It's
Okay.
essential without the L.
Okay. Let's just make up new words by just spell something wrong. I like that. All right, now, so what happened to me was, I didn't know this. I felt a pain in my esophagus.
What did you do?
Well, I went for one of the drinks, so I took the vinegar. In my head, I thought maybe I had too much base. I wouldn't know what the pain would come from, so I gargled and drank some vinegar. That didn't help because what I just did was I added more what? I added more H pluses.
Oh my god.
Yeah.
Are you like holding your chest? You're
Basically, I'm in pain right here, like a bad heartburn all the way down. Like all of my mouth here. So then I grabbed, knowing full well that did not help, I grabbed the baking soda solution. And I gargled that. And that did help, but there was an issue with that.
Did you have to like go to the hospital or something?
Eventually, yes.
Oh my god.
The issue was, do you guys know what the volcano reaction is?
Yeah.
Oh
You
my-
take
oh my
vinegar
God.
with baking soda, and it makes CO2 bubbles. So because I had so much acid in my esophagus, when I gargled and drank this very thick sodium hydroxide solution, I had lava foaming out. Now, it wasn't just foaming out. The first part ejected foam out. No. The students weren't believing any of this. Once they saw the foam ejecting, they ran and screamed because it ejected out like Exorcist with the like. But then it started. Remember the reaction with the foam and the hydrogen peroxide, elephant's toothpaste. So it ejected out, but then it started coming out like slowly. Like I was talking, and it started
Oh my
coming.
god, did we like get help?
I looked like I was a rapid science teacher.
Did it hit anybody?
No, but that felt better because it definitely neutralized.
So what did they do?
But I looked like
Oh my god.
he's a zombie. He's foaming from the
Oh
mouth.
my god. Did they like run to get help?
No, eventually I went to the emergency room and I had to explain to the doctor what happened, and I just felt he was not very understanding. So let me get this straight. You put acid in your throat. Well, it was new. I thought it was neutralized. So you tried to make sure. Like I used to give me a whole lecture how idiotic I was. He was right. But thank gosh I drank this. They said I probably would have perforated this esophagus, or I would have done some real damage if I didn't neutralize the extra acid with the basic solution. But that wasn't my first time having issues.
Why
I was in college, minding my own business. Okay? And what was happening was I was being 6'9" in a 6-foot world, or 5'10" world really, I knocked over a strong acid on my jeans. Now, good thing I thought that the lab tech, this is like usually a postdoctorate PhD trying to get his, whatever, they're working in the lab, looked at me, scratched his head. Now he had like a lot of hair. I don't know if he's ever combed. Like when he scratched his head, his hand disappeared. He would fool around, like pull like beakers out of his hair. It's like, it was gross. Any case, so he scratched his head so his hand disappeared, and he looked at me. So I had strong acid on my jeans, okay, and I felt the burning sensation. So I was panicking. What the heck do I know? So what he did is he grabbed another bottle and he just poured it on my leg. What did he pour on my leg? Poured a strong base. Now, as you can see, for this to work perfectly, don't I have to match all the hydroxides with the H pluses for this to work? So if I'm off by a little bit, it's not going to work. So he just splashed strong base on my leg. Of course, here was my spill with the strong acid. His strong base got me like right here.
Why are some just so reckless? They're just like, throw this on it. Oh my God.
Now, he scratched his head again and he grabbed another bottle. Now what do you think he was grabbing now? Yeah, to neutralize the base. Now, I realized then I was just a what? A pawn, an undergraduate pawn for his own personal what? Right. So at that point, I ran to the shower. Because at that point, my legs were burning. Because the place where he didn't get the acid, I felt it. And I took a public shower for the only time in my life. And I pulled the cord, and I was basically, by the time I was done, I was soaking wet, and the pants have unraveled down. Now this was, of course, February in Massachusetts, so that was pretty cold. Now I'm soaking wet in the lab, because someone sprayed up on me too, so it was like burning holes in my clothes, and also mostly around here. So I'm soaking wet, and they always have clothes for this scenario. But they don't have clothes for people like me. No, so they gave me the standard college, sweatshirt and sweatpants. But as you can see, they didn't have extra tall, extra large, okay? I swear the guy went in and grabbed the small stuff he could find. So I had a skin tight. Now, University of Massachusetts is some big words. But when I put the sweatshirt on, it was like this little bit. So it was skin tight. I didn't want to talk about the pants. It looked like yoga pants, and they weren't even in yet. I didn't even think yoga pants were ever in for guys. So I basically ran home that night running. And people were like, what was that? And just ran by. I'm not sure. Unfortunately, the University of Massachusetts, where I lived, there's 21 floors. I lived on the 17th floor. So I tried to sneak into the elevator. I was going to run up the stairs. I thought about that. But people hanged out in the stairs. So I went to the elevator. Of course, the dining hall just got out or going in. So there was like at every floor I had to stop. Hey, how's it going? What do? You just say, I'm number one. Can you push that for me? Thanks. Any case, that's what neutralization is. Yeah. Okay.
Wait, you could still do the demonstration, just not drink.
I could. I'm just not going to do it anymore. Okay. Any case, that's what neutralization is. So my friends in chemistry, neutralization is matching hydroxides from the base to the H pluses. So here we go. We already did this one. So follow along with me. Okay. H plus. Oops. H plus and the OH minus come off to make what? Make water. And what's left over? I don't know what's going on here. NaCl. So you need to know, party people, an acid plus a base makes salt and water. Correct. That's a neutralization reaction. Now, my friends in chemistry, what is this really? What kind of reaction is this? We've studied these types of reactions. Now, these are called neutralization reactions, but what could you call them also? Double replacement. Correct. This positive hooks with this negative to make the water, which really wants to come together because water does not like to be ions, and these come together. Chemical names you don't have to really do in this course, but it's hydrochloric acid, sodium hydroxide. You should know the name of this salt is sodium chloride, and of course water. Let's go on to number 2. What would be this reaction? How would I write this reaction? So I had a strong, well, let's do number 2. Let's be crazy. What was that? So what do I have here? Well, I know the H in front denotes an acid. and the hydroxide with the base come together to make what? Water. Now some people like writing HOH. Ho. You can write it that way to see that because the hydroxide came with the H, no big deal. And then what's the name of my salt? KNO3. So like before, if I give you an acid and base, you should be able to tell me what kind of salt is made. Now do we have to balance this? Well, of course you have to balance it, but is it balanced? Well, when you balance, party people, keep the polyatomic ions together. Here's one nitrate, here's one nitrate, here's one hydroxide, here's one hydroxide. Here's one H outside the hydroxide, here's one H. So it might be nice to keep the water as whole, so you can easily balance it. Okay? And is this solution acidic or basic or neutral? What's the pH of this solution? All the acid, we can assume that all the acid was mixed with all the base of equal concentration. It's neutral, absolutely. That's why they call it a neutralization reaction. Yeah, they should be for your class. 1 and 2. And then, of course, this one is also neutral, which is a pH of what? pH of 7. In this class, you always have strong acid, strong base, so it's always going to be neutral. Okay. So pretty easy stuff. Let's do number 4. We're going to skip number 3. Let's do number 4. So what am I definitely going to make over here? Definitely water. That's a product of neutralization. We'll write it as HOH. Ho. And then what's the salt? Yeah, what charge is lithium? Right, it's a group 1 ion. What charge is a sulfate ion? Yep, from table what the heck is that? It's -2. So I've got lithium who's +1. Sulfite as a cluster of nonmetals is -2. So what's the formula? Li2SO4, correct. Now my friends in chemistry, is this balanced? No. Have we done this before somewhere? Here we are doing something we've already learned, and we're doing it again. Do you see how this course constantly keeps using stuff that we've learned and keeps applying it? We've done double replacement. Neutralization is an example of double replacement. Now, of course, I have 2 lithiums. I have 1 lithium, so what do I have to do to balance there? Put a 2 in front, yes. Okay. And I have 1 sulfate, 1 sulfate, 1 hydroxide, 1 hydroxide. So are we balanced?
No, the 2 goes on the other side.
Yeah, it definitely does. Where's the 2 go? 2 for what? The H's, so we have to put 2 here. Did I do that right? Gotta watch me. Now this gives me what? 2 H's outside the 2 H's outside the hydroxide. Now wait a minute. This gives me 2 hydroxides. I only have 1 hydroxide. What do I have to do here? 2 in front. And now I'm balanced. Okay, what is the resulting pH when I add a strong base to a strong acid, assuming they're equal concentrations? pH is 7 is neutral. Okay, so here is what you have to know. You have to be able to recognize this to be a neutralization reaction, which is really a double replacement. You have to be able to predict what the salt is going to be, okay, from double replacement. And you should know that if you're adding equal amounts of an acid and base, they're going to match up and neutralize each other. That's all there is to it. Now, number 7 is important. This is the last little piece. Number 7 is really important, okay? And I'm going to do it up here for a second. If I take this reaction above here, okay? Now, let's write the ions out. Here's hydrochloric acid, breaks apart to H plus and Cl negative. Sodium plus breaks apart to Na plus and OH minus. Now, as we just talked about, they're going to double replace. The H plus is going to find the hydroxide. And then what we're going to happen is we're going to make water. And then we're going to have Na plus and Cl negative, which, by the way, doesn't make it precipitate. It's soluble. So when they say over here, what is the net ion reaction? You're going to cancel out the ions that are really doing nothing. What ions are doing nothing right here? They're not part of any reaction. Which ones are free on this side and still free? Yeah, so the Na and Cl are called spectators. They're not doing anything in this reaction. So the overall reaction is H plus from the acid plus the hydroxide from the base makes water. That's what the net overall result is. When you say net, it's the overall. Okay? So for number 7, this is what I write. H plus hydroxide gives me water. I'm sure that's not noisy enough. Okay. Backside. Flip it over 9 times. Okay, number 8. How many moles of KOH needed to neutralize 1.5 moles of HCl? I have 1.5 moles of an acid. How many moles of KOH do I need? What is neutralization? The same number. Oh my gosh. That's so difficult. Take a break. Break's over. So the answer is 1.5. I'm sure my video is not moving at all either. Yeah. There are people who need to watch this that are not here. So, thanks. Okay. This one's a little tricky. How many moles of base are needed to neutralize this acid? I have 1.5 moles of this acid. How much base do I need to neutralize it? You would think the same, but you're not trusting me, and you're right. Look at this acid. This acid gives off 1 H per molecule. This acid gives off 2. Ah, so if I have 1.5 moles of this, don't I really have 3 moles of H pluses?
Wait, how do you have 3?
Ah, because for every one of these, how many H's? Have we done that ratio question ever? Every one of there's 2 H's. So I really have 3 moles of H pluses. This only has 1 OH coming off, so you would need 3 moles of NaOH to neutralize that.
Don't you also know because 1.5 plus 1.5 is...
Yeah, that works too. So you would say 3 moles of base. How many grams? We can convert to grams, okay, from the moles. I'm not going to do that. Okay. Number 10. I introduced to you a brand new called neutralization or titration reaction. Okay, now pay attention. This is not hard. It's the last little piece of this unit, and we're done with this unit. We're going to have another test over the weekend. Okay, so table T, if I can turn to, which I'm having problems. Okay, we'll pick this up last 10 minutes when you get back.